Hello YouTube, Rick Wilson here. We're going to do a matter of time part 2, how light can escape from a black hole. In part 1, a matter of time, I had a couple comments about Coco. I guess she was playing in the background behind me and I didn't know it, but she got a couple comments about being a cool kitty. See her little white boots and her black toes in the middle of her white boots. She's a snowshoe kitty. There's only about 1,000 of these in the whole world, and so she's a special little kitty. But and then I need to do another video. She's grown a little bit since the last video. I've got about 5 Coco videos on here. But anyway, let's get back to the science. How light can escape a black hole. Now, Einstein predicted that light would bend around a massive object like the sun, and that light can be bent by gravity. And he did prove that. They did an experiment where there was a total solar eclipse, and they took pictures of the sun, and when the sun was completely blocked out by the moon, they could see stars right over top of the moon. The stars that were actually behind the sun. And the reason for that is, here's the sun, and if you get something with enough mass, it can bend light like that. And that's all it can do. It can only bend it a little bit. Light doesn't react to gravity as much as regular matter does. So I think light might have a tiny little bit of mass, nowhere near what regular matter does, but for it to be bent by gravity, they say it has no mass, but it must have a tiny bit of mass, because I don't see how it can bend with gravity. And I'm going to use the term gravity in this video because it's easier. I can easily substitute time differential like my last video, but it's just easier to say gravity. It all works the same, so it makes no difference. Okay, so light can be bent by gravity. Also, the black hole itself proves that light can be bent by gravity, because light, once it enters the event horizon and is trapped by the singularity and the gravity of the singularity, it doesn't escape. It's trapped. So light is affected by gravity. Okay, now let's go to the black hole. The black hole is just a little singularity. It's just a little pinpoint. And I don't care how big it looks through a telescope. If you can see the black hole with a telescope, some black holes are bigger than others in size, but that's not the singularity's bigger. It might be a more massive black hole, it might be a less massive black hole. All that matters is as far as the size. Well, I take that back. Actually, the event horizon would be determined. The event horizon is what you would see is the size, and the event horizon is determined by how much gravity. The more gravity, the bigger the event horizon. And which also means the black hole must have more mass. But the black hole itself is just a tiny point in the center. Okay, so we're going to draw this event horizon around the black hole. And light can come near the black hole and just be bent, and it shoots off into space. If it comes in at more of an angle and crosses the event horizon, it's trapped by the gravity of the singularity, and this light will just spiral right down to the center. But actually it won't make it to the singularity, because there's matter compacted around the singularity. It'll hit the matter and then stop there. Now let me change this. Let me give you another example to make this more clear what I'm about to say. I haven't said it yet, but I'm about to, but this will make it more clear. Let's say you got the Earth and you got a meteor coming by the Earth. One of 3 things can happen when the meteor passes the Earth. It can be going too fast or not enough mass, and it'll just come near the Earth and be bent by the gravity and shoot off into space. The other option, option 2, is if it's moving too slow or its mass is too great and caught in our gravity of Earth, it'll spiral in and hit the earth. And there's a third option. The third thing that can happen is if it's moving at just the right speed and it has just the right mass, this meteor will go into an orbit around the earth and be trapped in an orbit. Just like our moon. You know, our moon's trapped in an orbit. That can happen too. Okay, so now let's go back to the black hole. Got your singularity. Got your event horizon. If the light comes in just outside the event horizon, it'll just be bent and shoot off into space. If the light comes in too steep and hits through the event horizon, it gets sucked into a spiral down to the black hole. And then there's the third option, which I've never heard anyone say. I have thought this up myself. The third option, if the light hits that event horizon at just the right angle, it'll be trapped in an orbit around the black hole. It'll actually that's what I think the event horizon would be made of, would be light. The event horizon itself would be made of light. You can't see this light because it's going in a circle. The light has to reach your eyes to see it. The photon has to hit your retina for you to see it. But if I had a little ring of light here going in a circle in front of me, it would look like a black donut. It wouldn't look like light. The light has to hit your eyes. If it's never leaving the circle, that would just look like a black donut. And that's what the black hole looks like. Even though the event horizon itself is made of light that has been trapped, only the small percent of light that has hit it at just the right angle, and it's trapped in an orbit. And now you got other light that is slightly less of an angle, and it might make it just inside the event horizon, and it still goes in a decaying orbit. It'll orbit the black hole, but slowly be decaying in its orbit until it reaches the center. And I believe some of this light that's trapped in the full orbit, it would actually be at the event horizon. Any light that is 1 centimeter outside the event horizon would not be trapped and pass on into space. Any light that moves even 1 centimeter inside the event horizon will be trapped in a decaying orbit and eventually make it to the center. But some of the light, a small percent, would hit at just the right angle, and it would be trapped in an orbit exactly at the event horizon. The gravity is just enough to keep it in an orbit, and that light could orbit the black hole for many years. The light and more light gets trapped, more light gets trapped. So the event horizon, in my opinion, could actually be made of light. Even though it would appear black to us from the outside, it could be a ring of light that is so intense, maybe possibly even laser intensity. So if you were to enter into a black hole, it would look black. But as you cross the event horizon, you would see the brightest light in the universe. So the black hole would go from the darkest object in the universe to one of the brightest. And then inside the event horizon would be light, and in decaying orbits. It's working its way down to the center. Okay, now let's go back to how can the light escape? Now I haven't covered how it escaped. I covered how it's trapped. It's trapped in a decaying orbit. It gets sucked into the singularity, or it's trapped in a permanent orbit right at the event horizon. But either way, it can't now escape the black hole. There is a way for it to escape. If two black holes pass each other very quickly, what you'll end up with then, here's your black hole, here's the second black hole, here's one event horizon, and there's the other event horizon. Notice the event horizon, the singularity is not in the center of the event horizon anymore, because on this side, here's the singularity. On this side, you've got the gravity from this singularity, but you've got the gravity from this singularity adding to it So you got, if a piece of matter was right here, it would feel the gravity from this black hole, but it would also feel the gravity from this black hole. And the additional gravity would cause the event horizon to move away from the singularity on this side. Now on this side, the gravities are canceling each other out. So you could have two black holes, you know, this close to each other. And if you pass right between them, the gravity here and the gravity there will cancel out, and you would not be drawn into either black hole. You would just shoot right on past both of them. And because the gravity cancels out, the event horizon under less intense, because of the cancellation of this gravity, the event horizon would move in closer to the singularity. Now you have this light that was spinning in the event horizon, the light that's trapped in a perfect orbit right at the event horizon. Well, as this event horizon pulls in when these two black holes pass, some of the light that's trapped in the event horizon moves in, some of that light escapes. And it would escape in just a brilliant flash. It would be over with in a second, because only the light that's in an orbit would be able to escape. Light moves at the speed of light, so it would only take a millionth of a second or so, and all the light in the ring that could escape will have already escaped, and there would be no more light left behind to escape. So as these black holes pass each other, you would just get a brilliant flash of light, and then they would pass. And now how can I prove this? Well, all I got to do is find two black holes that are about to pass each other. That's all I got to do to prove it. Yeah, chance of that happening. So what I'm hoping for to prove my theory, what I would be more likely to hope for would be a black hole and a second black hole in an orbit around that black hole in a long elliptical orbit, so that only periodically would they come close and pass each other. And each time they did, there would be a flash of light come out of the event horizon. And so what I'm hoping that there's some scientists out here who have seen a flash of light that happens on a periodic basis out there in space somewhere, and they can't explain it. And this could be it. So that's what I would hope. I would hope that somebody out there that has a periodic flash of light happening in the heavens and they can't figure it out, and then maybe they'll see my video and go, hey, maybe that's what I'm looking at. So that's what I'm hoping. Okay, so that's how the light escapes. But before I go, let me use a little bit of imagination now, okay? I want to talk about what the inside of that black hole looks like. Go! Don't make so much noise. I'm trying to do a video. She's over there playing with her toy. Okay, the black hole, you got your singularity, and you got your event horizon. Okay, matter passes past the event horizon, trapped by the black hole, sucked down to the singularity. Okay, but the singularity is just a pinpoint, and there's a lot of matter, and this whole thing is spinning very rapidly. Very rapid. Black holes spin very rapidly, and this matter actually compacts. It starts compacting, and it would actually be in layers under there, because the matter would come in and hit and get compacted, and then it's all spinning and it's all slowly moving down toward the singularity. Now as this matter moves down, it gets more and more compacted. First, the space between the atoms gets lost until the atoms are actually all touching each other, and then you get deep. That would be like this layer, and then you get deeper, and the atoms actually collapse down to the atoms, and the atoms then collapse down. The protons and the electrons and the neutrons, they all just get smashed together under the intense gravity, and then as it gets even closer, there's another layer there where even those get smashed down farther, right down into quarks. So right, the layer closest to singularity would be a soup of quarks made of all different kinds of matter. And then there would be a layer on top of that that would be atoms, smashed atoms, and then layers on top of that of molecules. and with all the space squeezed out of them. And then on top of that, and this is where it gets weird, on top of that, in my mind, I see an ocean of photons from the light. The light that's spiraling in, it hits the matter and just sticks. Normally when light hits matter like the wall, it'll bounce and come back to your eye, and that's how you see the wall. But the gravity is so intense, the light can't really bounce. So once the light hits the matter down here, it just sticks. The photon stops. However, the photon is not attracted by gravity as strongly as matter. So these dead photons would be buoyant. They're not attracted by the gravity as strongly as gravity. They would float. They would be buoyant. The dead photons would float on top of the matter. So what I can imagine in my mind is an ocean of photons on top of the crushed matter. And then between that and my mind just went blank. I'm back. I had to go Google that because my mind went so blank. It's event horizon. It just, my mind, I don't know why, it just slipped my mind. I couldn't think of that. Okay, so between the matter, the photon ocean, and the event horizon would be an atmosphere of light that's in a decaying orbit. So it would be like a planet with the core and then the mantle and the oceans and light. And I could even see, light has a pressure. They're talking about building a spacecraft with a giant sail that collects light from the sun to push it. And they're talking you could actually go from star to star like that with a sail that collects starlight. So this force from the light, as it plows into this ocean of dead photons, I can see it pushing them a little bit. This ocean of photons that is buoyant because it's not pulled by gravity as strong as regular matter, so the photons would float on top of the matter. I could see there being waves there. So you could have inside the black hole would be an atmosphere of light and an ocean of photons with waves. And now I know some of you saying, hey, the black hole's spinning 1,000 times a second. So how could that be? Well, you got to remember, time inside the black hole has slowed down tremendously. A lot of things that enter the black hole might take 1,000,000 years to actually reach the center because time has slowed down so immensely. So I could see this ocean of waves inside the black hole actually having waves that roll along. Now what we see is spinning 1,000 times a second, but that's from our time. If you move to the time inside the black hole, it's a much, much, much slower time. A second may pass by in the black hole, and 1,000 years might pass by here on Earth. It's a pretty strange critter, but that's about it. Like I said, if two black holes pass closely by, the event horizons between the two black holes move inward, and this ring of light that is trapped in the event horizon, at the event horizon, could escape. Some of it could escape. And that's it. That's my video. I'm sorry my mind blanked out, but I will have edited it and put it back. It took me 10 minutes to go figure out event horizon. My mind just went, I don't know. Maybe I've been smoking too much shit. I don't know. Anyway, I'll try to do some other videos. Everybody's screaming for a Yellowstone update. I haven't been following Yellowstone too much lately. I've got a life outside of YouTube, people. I mean, but I've had mainly health problems. Like I said, I went to physical therapy for 4 weeks. I've been having teeth pulled. 2 days ago, I may have had a small heart attack. I got an appointment tomorrow. I'm going to see a doctor, and they're going to check and see what happened. Either it was a really bad anxiety attack or a small heart attack. So don't be deceived. I have to put on kind of an act on some of these videos that I'm better than what I am. And but anyway, I'm gonna try to get. I'll try to get in and look at. I might do a basic update on Yellowstone because everybody's wanting one. I want to do another Coco video because she's growing, and I haven't made a video. She's twice the size as she was the last video. I want to do the Yellowstone 25 years ago. I got more projects than I got time, plus my job. And, today was my day off, and they called me in, and I've only got 20 minutes right at the moment. I gotta leave to go get my wife at the hospital. She works at the hospital. So yeah, we'll see y'all later, and I'll try to get these videos out, people. But like I said, I only do what I can when I can. Okay, and like I said, I haven't even looked at the Yellowstone stuff in a couple weeks, so I'll try to get on there and look at it and do a report. I know the other people, the doomsayers, have been going crazy with stuff, but I still think it's mostly small stuff, and they make a big deal about it. But I'll try to get something on here in the next day or two. So see y'all later.